Hey kids, Mr. Murray here, Mr. Murray's Math Land, and today we're talking about compound inequalities, and versus or statements. And you'll notice in these problems that they're already solved, meaning the variables are already isolated for you, because I think by this point you're probably pretty good at getting down to these if you remember to switch the signs at certain times, things like that. And this video is just about helping you determine what the final result is from those two individual inequalities and some of the special situations that occur. So that's just what this short video is focused on. So to do that, if you find you're having trouble, just remember this. If you're dealing with an or, just think of when you use the word or, only one of the statements has to be true, not both, this or that. So when you're talking about these, or is going to be any part of the number line that is covered is part of the solution. But when it comes to ands, I mean, just think of the difference when you use the word and. This and that means both things have to be true. Both have to be true, which means you're going to be looking for where the two inequality graphs overlap each other. That would be the region where both are true. So, and you're looking for overlap, or you don't really care if only one is true or both are true, just any part of the number line covered. Okay, so let's see a few examples how this might play out. The first one, x is less than -1 or x is greater than or equal to 3. So x is less than -1, open circle at -1, shaded to the left, or x is greater than or equal to 3. There we go. That's sort of the what I've been calling the normal or situation. Two arrows going in the opposite direction with no overlap. And yes, when we say any part of the number line that's covered, means all of these numbers right here are true for this inequality. All of these numbers from here on out are true for this one. So these are all the numbers that will make this or that true. Basically, only the ones in the middle are not part of the solution. So there's your final answer, and it's already done for you, really. Nothing really to write here other than rewriting that. Now number 2, x is less than 4 and x is greater than -2. So let's suppose you've been having difficulties with these, and you know what, you just say, I want to graph these individually. X is less than 4, open circle, shaded to the left. We've been doing that last week. We're all good with it. Now I'll use a different color just to make this one stand out. And x is greater than -2. So that would be an open circle at -2, but shaded to the right. So you see, those are the two separate inequalities, but the solution is where both are true, this and that. So where do the numbers overlap? Where are both true? That would be everywhere in the middle here. And that's what we kind of have been calling the normal and. So unfortunately though, if you do this, if you take this approach, what you get is kind of a messy graph. And so you're expected to draw a final graph that is the summary of this, make it look nice here. And so the final solution is everything that's between -2 and 4. And a lot of you have been able to kind of see this anyway. Hey, these are the numbers that are less than 4 and greater than -2, and only in between there is what we're looking for. So there's our graphic solution, our final graph. And writing the solution would be writing it as that triple format, that triple compound format of -2 is less than x, which is less than 4. So that's the way you would write it. In a final answer, you would never use the word and in your solution. You would use that format. Okay, well those are the two basic ones, but just showing you how you could use this strategy of any part of the number line covered for or versus overlap for and. So let's take a look at these examples here. We've got another and here. So and, I'm going to use two colors just to make them stand out. So x is less than -1. open circle at -1, shaded to the left, and x is greater than or equal to 3. Closed circle, shaded to the right. Where are the numbers that are true for this and that? Are there any numbers that are less than -1 and greater than or equal to 3? No, and as you can see, these numbers never overlap, which is what you're looking for with and. So if there's no overlap, that's just the way of trying to tell you that there's no set of numbers that are true for both of these, meaning there's no solution. But again, I can't leave this as a final graph. I was sort of using this as a rough draft to help me figure out the final answer. And I'm not going to go crazy and redraw the whole thing, but the final answer is no solution, and that's an empty number line. So you can't just leave it like this because you have to interpret it, and you just can't leave this because this would look to somebody like, hey, is this an or? Maybe these are part of the solution. Nope. Our final solution was no solution with an empty number line. Okay, number 4, x is less than 4 or x is greater than -2. Okay, x is less than 4, open circle at 4, shaded to the left. X is greater than -2, open circle at -2, shaded to the right. And since it's an or, this is not the typical or where they don't overlap, where it's two opposite ones. So be careful, just think about it. Where are the numbers that are true for this or that? Well, all the numbers here are true. These are all the numbers that are less than 4. So this has got it covered. In the middle, this is where both are true. And here, beyond that, these are the numbers that are true for x is greater than -2. So you see the number line is always covered by at least one of them. So there's every number is part of the solution. Any number you can think of is either less than 4 or greater than -2. And there's a few that are both, but that's not what this one's asking for, just or, so either or. And so our final answer is, hey, this is all real numbers, all real numbers. And again, I'm going to draw a final graph for these special ones. It's up to you to kind of communicate. And all real numbers means draw a full number line. So just draw one continuous line. That kind of shows, hey, we're covering it all. And there we go. I actually used the same exact inequalities between these two sets of problems, but the only thing I did was I changed this from or to and this from and to or, just so you could see how it drastically changes the actual final answer you give. Okay, so let's just see 2 more and then we're good here. So 2 more, 1 or, 1 and. Hopefully you're getting the hang of this. If not, you can always rewind it, watch it again, or of course ask questions. This one right here, we got an or. So x is less than -1, open circle at -1, shaded to the left, or x is less than or equal to 3. So this again is not your typical sort of or because the arrows are going in the same direction. But with or, remember, we're just talking about any part of the number line that's covered. They don't have to both be true, just at least one of them has to be true. So starting here, these are the numbers that are less than or equal to 3. So these would make it true. And beyond here, these are the numbers that are true for both. Great. Basically, everything from 3 down is part of the solution. Everything out here is not true for either one, so this is our solution. So you see what I'm doing? I'm just shading any part of the number line that's covered by at least one of the inequalities. So if I do this though, it does look a little messy because I want one final answer here. And what is the answer? The answer is everything to the left of 3 is part of the solution. So that's x is less than or equal to 3. So I'm just going to draw that. Why should I have those two number lines, looking messy there? just going to draw x is less than or equal to 3. That's a single way to represent that solution, the simplest way to do it. Okay, and the last one here, x is greater than -2 and x is greater than 1. So x is greater than -2, open circle, shaded to the right, and x is greater than 1. So I'll use a different color because it's and I want to see these two clearly. Open circle at 1, shaded to the right. With an and, remember, I'm looking for where both are true, this and that. So definitely not out here, neither one's true. Definitely not here, only this one is true, the red one. And here's where I'm looking, where do they overlap? Where do they overlap? And you're looking for overlap. And that's what it is. It's all the numbers beyond 1, or in other words, all the x values greater than 1. That's your solution. And your number line should show that. Here's 1, here's 0, here's 2. The solution is all the x values greater than 1. And that's that. So, both of these kind of showed when the arrows go in the same direction. If it's an or, you're kind of just putting them together, and this one, this smaller one, quote unquote smaller one, is kind of irrelevant. When you're talking and, you only care about where they both start. So this first one was kind of the irrelevant one, and only this one was the answer. So you'll see that play out from time to time. So hopefully you got to see some special solutions from all these, and if you have any questions, please feel free to ask.